says here, and we did do a little bit of inverses with our sine, cosine, and tangent functions earlier in the year, but we talked about how you sometimes had to restrict part of your graph because for something to be an inverse, it has to be 1-to-1. For something to be a function, we know the x's have to be 1-to-1, right? You always check it with like the vertical line test to see if it's a function. But you also, for it to be an inverse, need your y values to be 1-to-1, which if you check the x's with a vertical line test, we would check our y's with a horizontal line test. Okay? The reason being is because when you take the inverse of something, like it says right here, if this point was in one of the functions, then the other should have the same point but reversed because your x's and y's switch when you have an inverse, right? So that's the reason we need the original function to not only pass the vertical line test, we need it to pass the horizontal line test because when I take the inverse, the x's and y's are going to switch. So those y's that I was checking with my horizontal line test are now going to be the x's that I would check with a vertical line test when I switch them. So we need no x's to repeat and no y's to repeat in order for something to have an inverse. So it says here that we are going to graph each one of these functions. You can use your graphing calculator if you want a better view than what's shown here. So they're on the chargers over there. Not many people have been using them today. But if you want to grab one, if you don't have your own and you want a better view of what's going to be in here, you can grab a graphing calculator. All they did was type this function into the calculator, and it gave them this view here. So it is a little more zoomed out than maybe you might like if you were the one who was trying to identify points, but it gives you the gist of what the image should be. It says, with this, we are going to apply that horizontal line test and determine whether the function should have an inverse, and we'll say yes or no. Okay, so we know it's a function, right? This is our cubic function. And we know from our transformations that we talked about the other day, it's just like the parent function, but it has been shifted down 3. And what does this mean? A compression, right? So normally a stretch like 4 would make it taller. A compression is going to push all the points down. So that's why this looks a little bit more flat in this region than in the parent function, just because all the points have been pushed down just a little bit more. All right, so we know that it's a function, right? We know that it passes the vertical line test. What about horizontal line tests? If I were to put a horizontal line anywhere on this graph, is it ever going to hit more than one point?
Yeah, no.
No, it shouldn't. Where is it going to hit?
Like that, like part where it's just like flat.
Well, remember we just said we know what the parent function looks like.
Yeah.
Looks something like this. And I said that it still is that same function, but it's been compressed, so it just pushed it a little flatter. But that doesn't mean that the points are repeating now, right? It doesn't change the parent function.
All right.
So it just looks a little bit flatter, like more laid out this way, but it's not going to have repeating points now just because I multiplied the points by 1/4. Okay? So, because it does pass the horizontal line test, that tells us, yes, it should have an inverse. So, our answer here would be yes, which is what they said, and they go on to explain why. It says the inverse function would exist. It's not possible to find a horizontal line that would intersect at more than one point on this graph. Therefore, it must have an inverse. Okay? For part B, okay, this one, like I said, a little more zoomed out. If you were to look at it on your calculator, you'd see a little bit more of kind of a slant in it. So it'd look a little bit more like this, but you still get the gist. What do you guys think? On part B, would it pass the horizontal line test? Definitely not, right? It's going to hit at least two spots everywhere we would draw a line. So our answer here is no, and they go on to explain why. This cannot have an inverse because it does not pass the horizontal line test. So an inverse will not exist. So keeping that in mind, in this next section, They want us to graph these functions without a calculator, since we know what the parent functions look like, and these are not any kind of a crazy transformation. We should be able to draw them. Once we draw them, it says we're going to apply the horizontal line test and then determine if we think the function exists or not. So we're going to say yes or no. Okay? So I'll do the first one with you guys. Right here, this is our rational parent function with no shifts, right? So where are the asymptotes in this rational function? So we have a vertical asymptote at 0, and we have a horizontal asymptote at 0. And it's going to look something like this, right? Okay, so what do you guys think? Is it 1-to-1? Yeah, it's going to pass both the vertical line test, no x's repeating, and it's going to pass the horizontal line test because no y values are going to repeat, right? So therefore, what do you guys think? Is it going to have an inverse function? My answer would be yes. So that's all we got to do. All right? I want you guys to try 2, 3, and 4. So you'll draw a sketch and then tell me yes or no. Should it have an inverse? If you're having a hard time remembering any of those functions, you can pull back out your parent function notes. I believe those were 4.6 notes. You want to look at them? Well, the horizontal line test is what's going to tell us about the inverse, but all of these should pass the vertical line test because they're all functions, right? Yeah. So the horizontal is going to be what really determines it for us.
Yeah. It's like,
You should already know them. These are all ones from algebra 2. You never took algebra 2?
did you move it left?
Oh, yeah.
They did.
I didn't move it all. It was like that, right? It was down to the right.
Always.
No. Or is it just the?
I didn't do all these functions in 9 weeks. This takes like a whole year to do like a unit over each one of these functions.
Absolute value of x is always a negative for y. So if x is a negative, y is
He had like
That comes from these. So the reason you have to out is because the graph
Mr. Rogers has those in Chelsea.
I had this essay in English 1. I wrote it on the, he had us do it on the Edinburgh.
Yeah, she's one of the, like I stuck on my cheek.
And he didn't get it.
Okay.
So I've got to mix it.
All right. For example number 2, what's the parent function we're dealing with on number 2? Quadratic, right? So we know that's our parabola. Okay, and our parabola normally has a point right here on the origin, right? But this function has been shifted how? Down 5. Perfect. So I'm going to put point here. Okay, and then we should also know right here and right here we have points. How far away are those points from the origin? 1 and 1, right? So I've got 1 in this direction, 1 in this direction. Okay, that's enough for you to be able to give me a sketch. If you want to have more points on there, you can. The next point would be 2 over and 4 up if you wanted another set, but you don't have to have more than just the one on either side to get a good idea. So looks something like this. All right, so this does pass the vertical line test, right? We know it's a function. But what about the horizontal line test? No. So, does not pass the horizontal line test, so can this have an inverse function? No. So my answer here is no. Okay. What about for number 3? What's the parent function on number 3? Cubic. Very good. So we know our cubic function looks something like this, right? Normally has a point right here at 0, 0. But what do we know about this function? Shifted up 6. So that normal 0, 0 is now at 0, 6. What else do I know about this function? Reflected over the... Okay, so that means that basically all of my points that would have been above the x-axis would flip down, right? And vice versa. Now, we did shift up 6, so they may not literally be below, but we should know from our cubic function, we've got a point above the origin if we just go right 1 and up 1, right? Okay, but we said it's going to reflect, so now that point is going to go below. So I'm going to put that point right here 1 unit below. And then normally we have a point down 1 and left 1. That one's going to move up, right? Okay, so here's our approximate sketch. What do you guys think? Does it pass the vertical line test? Yes. What about the horizontal line test?
Yes.
So, will it have an inverse?
Yes.
Good. Okay, last one. Here's our absolute value, right? Looks something like this. Normally, this point right here, the vertex, is at the origin, but this has been shifted how? Vertically 3, right? So we're shifting up 3. What else do we know? So these 2 points are now going to go down, right?
The square root function is that what goes with that?
All right, so looks something like this. Do we pass the vertical line test here? Yes. Do we pass the horizontal line test here? No. So this one is not going to have an inverse. Okay. All right, flip it over on the back. So not only do we need to be able to determine if it has an inverse or not, they also want us to be able to then find the inverse function. So you also have done this before. They remind you of the steps right here. It says first thing you do is do the horizontal line test, so like what we just did, draw it, check. If you say yes, then find the inverse by doing this. It says what you're going to do is replace the f of x in the equation with the letter y. And then after you do that, you're going to switch the places of x and y in the equation. So we switch the x and y, and that will be your inverse function. But if we're going to have to graph something, we don't want it to say x equals the equation. We like it to be y equals the equation, right? So once you switch it, it says now solve the equation to get y by itself so that it'll be in the correct form. And then change your y out for this notation. This means inverse. Okay? And then if there are any restrictions, state those restrictions. So like if you need to say all the points except this part, then you would state that. Okay, so let's see here. For example number 1, first I got to check to see if I think it will even have an inverse by doing the horizontal line test. So I'm going to graph it first. My y-intercept for this graph is at -4, right? And my slope is 2. So we'll be going up 2 and over 1 in that positive direction. All right, so here is our function, f of x. So what do you guys think? Does it pass the vertical line test?
Yes.
Does it pass the horizontal line test? Yes, so it is 1 to 1, so you guys think it's going to have an inverse? Yes. Okay, so since we said yes, we now are expected to find that inverse function. So, step number 2 says that you need to replace f of x with y. So I'm going to mark out f of x, and I'm going to put the letter y in its place. It says once you've done that, to interchange x and y, basically switch their places. So I'm going to switch the x and the y's places in the equation. So now it'll be x equals 2y minus 4. All right, so that is the inverse equation. But if we're going to have to graph it, we want to know it in the form y equals. So I want to get the y by itself. In other words, solve the equation for y. So what would I do first? Add the 4. So I'd have x plus 4 equals 2y. Then what should we do? Divide by 2. All right, so y is equal to x plus 4 over 2. It said after you've done that, step number 3 says change out the y for the inverse notation, which is that f with that little negative 1 of x is equal to x plus 4 over 2. Okay, so if I'm unsure of what this looks like, I can always graph that. Remember, if you want to graph it, you can split that fraction up. You could also write this as like x over 2 plus 4 over 2, right? Which would be the same as 1/2 x plus 2. So if you wanted to graph it, you absolutely could. You would have a y-intercept of 2 and a slope of 1/2. So it would look something like this if I were to graph it. Graphing it is actually a pretty good way to determine if you found the correct equation, because your inverse functions should always be a reflection or have a line of symmetry along the line y equals x. So that would be this line. I'll draw it here in red so you can see it. Okay. So the purple line is our inverse function. The red line is the line that it should reflect over. And it looks like that's exactly what happens, right? There's mirror images of the purple points and the black points across that red line. So that's one way to check if you did it correctly. Another way is we said over here on the front page that anytime you have some point BA, the other one should have the point AB, right? Or in other words, the coordinates flip. So you could check a couple of the coordinate points. So looks like right here, that's the point 0, 2, right? And on the black line, I do have the point 2, 0. So in fact, I did have some points switch. So either of those would be good ways to check and make sure you came up with the correct equation right here. All right? Okay, I want you guys to try 2, 3, and 4. So all you have to do is draw the one in black, and then if you say yes, you need to find this equation right here. If you say no, then you don't need to find an equation.
I've got a question. Is that just like can't have facts be equal?
Right, don't plot any points where that's not true.
Gotcha.
I think that's, yeah, you're right. This has to be created. So Allie, the cutoff is around. So that's one.
Just don't do it.
Well, you graphed it, so the only part that you should see is this part over here, right? So then you tell me, does that pass vertical and horizontal lines has to
Like, no, like when you're doing the equation for the curves.
Oh, I said different question, like not this question.
I mean, like, so I know like you, since you're doing this part, it's gonna be yes.
Okay.
But like, when you're doing this part.
Oh, like when you go to solve, yeah, that
Yes.
won't affect how you solve. You'll just solve this equation. I gotcha.
Oh. Roughly the inverse, right? Yeah, minus.
This is the equation, this is a restriction. So that's the equation, follow steps 2 through 3 on the equation. So you said yes, so now you need to follow steps 2 through 3 on that part of the equation.
So like, oh.
That's wrong. What's not? Got the 2. So, should be -1, right? Wait, where's that turn to?
But you have to graph.
I know.
Just right
I
there.
realize it.
For the inverse.
That's right.
Oh, you don't have to draw the inverse, I was just showing you a way, if you needed to check it, you can draw it and see if it reflects on that line. But yeah, they didn't ask for you to graph it, so you don't have to graph the inverse.
But the restriction was what?
Just like that.
My English teacher's lecture yesterday. It's negative X, like what is the reflection of it? What is it?
The x is negative,
Yeah.
and that's a reflection over the y axis, if it's just the x is negative.
Okay.
Where'd you find the x negative?
Yeah, where did you find that?
Number 2. So I got, so y minus y squared.
Unless you wanna do that.
Okay.
Then you put it all up.
Like
y
it's
squared
track
minus
it,
2y
but
plus
it didn't
1
say like.
plus 2y. Hey, man.
That's not cool.
Look, I just told you, this part
It didn't,
is the
yesterday didn't say what
restriction,
day.
not part of the equation.
I'm not, again, I'm not a snitch, but
Oh.
This is the restriction, that's what I told you
Friday,
to
alright,
only
but that's,
graph.
that, no, my fault. It's
Oh.
4 shipments. One of them is the replicate.
yeah, look, I'll just wait till
Okay.
Just a quick question for you.
Actually, that piece will be here.
I'd
love to answer your question.
When you walk in,
So after that, you
What's
really
the
only have to have
first thing
memorized
the board-
the next
okay.
point. And the next point,
Oh,
it's just
okay.
like your
Blank thing.
parabola. Normally we go over one, up
Actually, it's
one.
not safe.
So here you go up one and over one.
The electronic one.
Right? And then after
The
that.
second
you
sentence
go
on
over
all
this
of it
section.
tomorrow.
That's
It was
enough
safe.
for you to have an idea of what it
it
was.
says put your phone up in a clear pocket.
That's free.
You can always add more if you want, but.
Oh, they shipped it.
You just have to
When did he call me?
That's what you want, but as I said right here, state in the.
Wait, Mom,
Put
these
the
are
part
still-
that you
Yeah,
want
it's
to
gonna be
put the part that you want.
Yeah, whatever day they call.
X. only where x is whatever. Kind of like here, they said, only draw it where x is greater than or equal to 1.
I don't know why. He was like, how much I showed back. He's
This should be shift down, not left or right. So what is x there?
It's called modern day technology, it's mirages.
Okay. All right. I think most of my guys over here have them all done, and you guys are wrapping it up. So let's go ahead and take a look. So for number 2, what was our parent function? Right. So our quadratic. And they also gave us this restriction, right? So they're saying only graph it where x is greater than or equal to 1. So normally our parabola would start at 0, 0, but it has been shifted. Where did it get shifted to? Right 1 and up 2. Perfect, because that would fall in this window, right? Because the x value there is 1. But I can't graph anything any further to the left, right? So I can plot another point here. And if you want to add more points, you're welcome to. You can add, you'd have one more if you started at 2. You'd have another one up here at 6. So you could graph an extra point if you'd like, but not necessary. We know it looks something like this, right? And we only are drawing that part because they did restrict us, right? Okay, so what do you guys think? Does this pass the vertical and horizontal line test?
Yes.
Okay, so our answer is yes. Then we need to find the inverse function. And how do I find the inverse function? Right. So we're going to have x is equal to y minus 1 squared plus 2, right? Where do I go from here? Not yet. What do we need to do first? Subtract the 2, right, to move it to the other side. Okay, so x minus 2 equals that y minus 1 squared. Then what? Now we take the square root. So we have the square root of x minus 2 is equal to y minus 1. Then what do we do? Add the 1. So square root of x minus 2. That plus 1 is not under the square root, right? Because we're moving it over after the fact. So it looks like this. So we replace our y. Our inverse function is the square root of x minus 2 plus 1. All right? Okay? All right, let's take a look at number 3. This one's our square root function, right? But where has it been shifted? Left 3. All right, no stretch, so we know there should be a point 1 over from there. And then you'd have 1 here if you want to add 1 more, but 2 points is plenty. We know it looks something like this, all right? What do you guys think? Does it pass vertical and horizontal? Okay, so my answer is yes. Then I am going to find the inverse. So, again, we switch the x and y. So I would have x is equal to the square root of y plus 3. Then what do we do? Perfect. Right. All right, so there is our inverse. All right, now some of you guys already pointed this out. I saw it on your paper as I was walking around. But if we graph a parabola, that would have been like if we graphed over here and we actually went ahead and graphed the other side, right? And then we know for a fact those wouldn't have been inverses of one another because we know this only has 1/2 to it, right? So what do I need to do to this equation? Right, get rid of the restriction that we don't want. So if I were to go and graph this, it's been shifted down 3. All right, and then I can plot some other points. And that's the part I want to keep, right? So I don't want to keep anything that would have been over here. So what part do I want to get rid of? Okay, and where does that happen? Right, so we only want to graph the part where x is greater than or equal to 0, right? Okay, good. All right, okay. And then for that last one, they said graph this parabola with no restrictions. So we're shifted up 4. So we look something like this. What do you guys think? Does it pass the test? No test. Okay, so it does not pass horizontal line test, so no inverse. I don't have anything to find. All right.